Alright, another draft physics video presentation. Fourth in a series of 4 videos covering the 4 major phenomenon of physics. I would argue gravity, which this video will be about. Then you have magnetism, and you have photon spectrum. That is all the kinds of photons, energy at a frequency. Stuff moving the speed of light we'll call energy. And whatever the fourth one is. Anyway, yeah, escaped my perception. Charge, the big one, yeah. Anyway, so this isn't charge gravity. Gravity's like charge. It has one element of charge, which is the attraction part, but it doesn't have the repulsion part. And the truth is, for gravity, there is no, it's a balance, frankly. Charge, objects that are gravitational are generally speaking not greatly charged. So charge, the idea of segregating the force and intensifying it through that segregation, magnetism even, doesn't play a role in the basic function of gravity. It doesn't have enough of an influence to overwhelm the gravitational influence by itself. So, although this is 2 plus 2 plus 2 physics, you only need the 1, the idea of force, and the 1, the idea of matter, something the force hits, and you only need 1 interaction to understand gravity, but there are 2. And it's just that the 2, the yin and the yang of charge, the plus and the minus, end up being gravitationally irrelevant in the fact that the protons and the electrons are doing exactly the opposite thing in every environment. And so for every plus there's a minus, and therefore you have a 0. And this is about the consequences of gravity. So gravity has 2 aspects, I would argue, to explain. The first is the creation of this idea of a tendency, let's just say, to move. Something moves in a direction because we put 2 things next to each other, and for some reason this thing is compelled to move this way and this thing is compelled to move this way. The other part of gravity is that we know that, at least some people will argue, it moves at the speed of light. So there's a force carrier, an idea of a communicator between these objects that moves at the speed of light. And so that creates this weird phenomenon of this thing, let's say, has a path, an orbital path, because of gravity, because it's always being attracted. No matter what position I put it in, it's attracted to the object, and therefore it moves in a circular path. Well, the idea would be is that if gravity was communicating this reason to move at the speed of light, that communication would be behind this velocity, and therefore by the time the message got back to this thing, it wouldn't be there. So the message would come back, this would send a message, the message would come back, and it come back too late because this thing's over here now, and the message is going to be missed because it's not in the right location anymore. So those are the 2 elements, right? There is the motivator, the thing that's causing the movement, and then this idea that, well, at the speed of light, that mechanism would have obvious failures. But that's presuming you haven't thought it all through, let's say. So I'll try to explain in the simplest terms, and there's all kinds of little subtleties, especially with the balancing of charge and all of that, but I don't think they're necessary for the purpose of this explanation. So if we understand the universe to be force around every object, so it comes from all directions, the obvious circumstance of gravity, so if I have 2 little objects in all of space, and that's all there are, just these 2 objects, so it's uncomplicated by any other object in the way. And the idea is that a force at any one time sticks, and then another force hits, that force leaves, and the new force sticks, and the new force sticks, and so only one of these little things sticks at a time. And every time there's a new force in, there's a force out. But the object moves in the direction of the force was moving. So when this thing hits, this object moves with that piece of force until it encounters another piece of force, until another piece hits it and changes its direction. So instead of going this way, it's going this way, or whatever the thing would be. and it reflects whatever way. It doesn't really matter how you understand the conservation, but it is conservational. That is, for every impact there's a change. So you could sort of understand that if two objects in all of space are very distant from each other, let's just say this is a great deal of distance, even though it doesn't look like it. I suppose I can fix that by going this way. Alright, so this force is always hitting, from all sides. Now you can understand that there's a sort of a shadow that happens, that the object will hit this object before it hits this object. So it would have, for this object to be balanced in the universe, right? So let's just say this object is the only one that exists. He would be getting hit by this arrow, right? No doubt about it. This arrow goes straight through and hit him. But instead it's going to end up hitting this object, and it's going to move this object to a new position. It's going to stick to it for a while, and it's going to move it something less than the speed of light. So let's say half the speed of light by sticking. And so this object is now going to move this distance, and that's going to absorb some time. It's going to, instead of getting where at a certain time it was expected here. Okay, so if this wasn't here, the change in the universe is, if this wasn't here, if this was the only object, this was expected at a certain time. With this object in the universe, this doesn't get here at the expected time. So there's an imbalance in the field around it, because now this arrow, this one that would have balanced another arrow coming this way, okay, now those two arrows aren't balanced because they were scheduled to hit this object within the same amount of time, and they didn't. So now this got an extra hit this way and no counter hit that way. So there's a kind of low pressure here, okay, because this energy was spending time moving this bit, this piece of matter. And you can see that obviously as that happens, as this one absorbs a piece of energy, this one ends up moving because it gets hit by a force, and it absorbs it and holds it for a longer period of time, right? If you got less energy coming this way, then you have more opportunity for energy to stick going this way. So it sticks longer because there's less force opposing it, less force changing it. So it spends more time doing this and less time doing that. And by doing that, it again does the same thing to this one. And back and forth and back and forth, and they keep accelerating this low pressure by moving. So every movement absorbs energy for a period of time, and by absorbing it for a period of time, it doesn't get where it was going. So that sort of explains the basic mechanism, like why things are attracted, is because movement absorbs energy. It occupies it. So absorb might not even be the right word. It captures energy. So movement means you captured energy, you trapped it for a period of time. The energy didn't go as fast as it was going. It didn't go the path it was going. You've altered its destiny. It doesn't get where it was going. And by not getting where it was going, the other thing moves. Now this is theoretically reasonable, and in experiments, I haven't found any actually videoed, where you create a system of, you can do it with a simulation, even of computer simulation, where if you just did that, where if you created little BBs moving in random directions, thousands of them, and put this universe in a box, and had the BBs reflect off the walls, a round box, and then you put two big objects in with those little objects, the two big objects would end up moving right into each other through this simple mechanism. They would create the motivating mechanism to attract, because they would in fact absorb just these little hits, and little hits would be the same as any other absorption of momentum by Newtonian rules. So you don't need to have some bent space mechanism, frankly, to explain it mechanically. You can explain it as just an external pressure, and the external pressure will constantly create low pressure in between objects. Now, the trick is the aberration argument, or the argument that this gravity is, the gravity you're in is the gravity you're creating, which is the wrong way to look at it. So if there were two objects, and they are in the process of consuming energy in these directions, you can sort of understand that from this object's perspective, microphone issue, speakers actually. All right, so where was I? Okay, there's this. Two objects are absorbing the energy. Damn, I knew there was a place I was going with this, and I wanted to. It's a point worth making. I could pause and think for a second. Annoying. I think I wanted to point out the asymmetry of perspective. So the idea would be is that these objects, from this one's perspective, it can't see something that moves. Say if I had another object here, say if these were two smaller objects, okay, and one was going this way, that is, it was capturing more force going that way, and the other one's capturing more force going this way. You can sort of understand that from this piece's perspective, this piece of mass's perspective, it will know about this change. This change means something to this one because this force was going to get here at a certain time and it didn't. That it can know about. But this force that got captured moving this object this way, it can't see it. It can't know that it happened. It can't know that a force bit hit this one and moved it this way, and that time changed for something out here. It has no way of seeing that. It won't change what's happening to this object in any substantial way except through the speed of light, in the sense that obviously there'll be some possibility of a reflection. So this is where it gets to the fundamental function, which is charge. So in the charge world, there is this constant communication between objects in the sense that some force does get trapped, has the possibility of getting trapped. But that's only a 50% possibility because you're just as likely to hit a proton as you are an electron, and so the force might not reflect. So you can't know too much about position. You know less about position, you'll know more about this gravity thing. But the simple argument is you can know about something that was going to happen to you. You can notice that change. But if something wasn't going to happen to you, you can't really know it. Sort of like how we live our lives. I mean, the stuff that's relevant to us is the stuff that affects us. We're not so aware of somebody else who has the broken leg. Anyway. So it's just something to be aware of in terms of the fact that there is this balance still existing. It's just that we can't see both sides of the equation. We see the stuff that's trapped coming towards us, not the stuff moving away from us. So you can sort of understand that when two objects are engaged in the gravitational dance, so to speak, they're not going to say if this thing had motion inside of it. That is, it's spinning, something spinning inside of it. The only motion that seems relevant to it is the motion this way. So we're saying that any motion is an absorption of energy for a period of time. So the motion going this way, that is any motion from this angle to this angle, okay, any motion that has a component in my direction, I'm going to be aware of the fact that energy was absorbed that may have hit me. And so obviously, unless they're really close together, you don't include all these other arrows, but they would be part of the equation. But anyway, so you'll see, okay, in terms of feeling less pressure, low pressure on this surface, you'll see this stuff, the energy that got occupied pushing little bits inside of this. Let's assume this is a big particle now, not a small one. And stuff can move inside of it. So there's stuff moving inside of it. You can say back and forth, it really doesn't matter. The point is that you can know about the force that didn't get to you, but you can't know that a force going away from you didn't get where it was going. So it's not relevant. So you're only seeing one side. So all you see is an absorption this way, an absorption this way, an absorption this way, absorption this way. You never see the counter absorption going the opposite way. So your perspective is completely biased in terms of what can affect you. So you see this part of the movement. you don't see this part. This part doesn't affect you. So even though this thing itself is in some sort of equilibrium or balance, you're only seeing half of the equilibrium. So the hotter something is, the more stuff is moving. In a sense, that's a gravitational function, because there's stuff moving towards you that has to be pushed. It has to absorb energy to move. So it's absorbed a bunch of arrows going this way by moving this way. But the other stuff moving this way, you'll never know. It won't, you'll have no way of feeling higher pressure because something moved away from you. So it's like the argument with photons. If I move away from you, I'm invisible. I move towards you, I'm more opaque. And the same argument here applies. All right. So the other concept would be is direction. So when these two objects do this thing, so I guess I could draw that so it's easier to see. Oh shit. Yeah. Well, I'm not going to go pick it up, so we'll just use the hand. Crude but functional, mostly. Well, not entirely. I don't need to make all that noise, thank you. This thing has got too much dust in it anyway. I really have to come up with a better system. Yes, something wet, sponge or something. Alright, I'll get to it eventually. So much to do on one man. It's just an awful lot to be corrected in the world. Alright, so if there were two objects, now the question would be, what does this world see out here, and what does something see out here? So these two objects are moving towards each other through this process of absorbing this energy. Well, what does a spectator in some other location see when that event is taking place? And the argument would be is they are absorbing and performing this gravitational function based on some geometry. Like they have a center of gravity, and in a way they're absorbing energy in all kinds of directions to move towards each other. So you can move towards each other by moving this way, but you can also move towards each other by moving this way. Alright, that's closer. So in a sense that these other directions count. So when two things are moving towards each other, they might not be taking a perfectly straight path. So their motion might have some of this and some of that and some of this, some of this. It might not be a perfectly straight path to getting closer. And so in that sense, there is places where it absorbed energy going this way. And then it absorbs some energy going this way, or this way, or this way, or this way. So the idea is it's radiating this change in the universe, that is it, moving towards, by absorbing energy in anything that has a component in this direction. So any of these directions count because they have a component in the direction towards or absorbing energy. And so everything is making this low pressure is being spread, not just in the direction that it's an obvious movement towards, it's also in all the directions that are an unobvious movement towards, all the not straight directions. So even though it's just a tiny 1 degree angle, it's still moving closer. By moving in that direction, it still moves closer to the other object. And so gravity is really being expelled by objects in all directions. So from something looking this way, it's going to see this object absorb energy this way. Alright, so it's going to see that, anything that impacts it. It's not going to see this object moving away, in net. So this object's moving away, you can't see that, that's becoming invisible. This object's becoming more visible, okay, and by being more visible, it means it absorbed energy that this thing should have got hit by. So this object's going to see it as something to move towards. And the same would be true as an object over here. Okay, so even though it's going to be, even though it's not at the same angle, it's seen a bunch of energy getting absorbed. All the lines going this way, there were absorptions, any movement that was this way, it saw that as an absence of force, so it's feeling the low pressure, and it likewise is going to move, okay, recognizing that it sees this one moved, and it's going to see maybe a little bit from this object, because now this object could also move a little bit this way. It's going to see a little bit of a less there too. So it's going to get the same impact from these two things moving. So the gravity isn't just back and forth between the object. The gravity that you're causing or absorbing, the energy you're absorbing, can be in any one of these directions that have a component towards you, and therefore the gravity you're expelling, that is the product on the universe, the change in the universe. The change is here, and 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 the change is here. And the inverse change from somebody on the opposite side is here, right? I don't know how to describe an inverted change, but I could just do a C backwards. So this side will see the changes caused by the motion this way. This side, anything on this side, will see changes in the motion this way. And so when we are in gravity, we're creating more gravity for something outside of me. So when these two objects are moving towards each other, they're creating gravity that will affect all these other objects out here. They're not just creating a change on each other, they're changing the universe all around them while they're making these changes of moving towards each other. So there's reason, so something out here is going to fall into the gravity these two things by interacting with each other created. That's the gravity it falls into. It doesn't fall into a gravity that is actually involved in making. That fixes the aberration argument, because the gravity you're in is the gravity of the whole object. See, the Earth is huge. The tiny amount of gravity I'm making is sort of irrelevant to the gravity I'm moving in. The gravity I'm moving in is the one created by all the other little bits inside of the Earth that are creating this little bit of extra gravity going in these extra directions. And that's the gravity I fall into, is the gravity left over. Gravity not used up by the motion of these two objects, but the gravity that created an emptiness here, and an emptiness here, and a low pressure here, and a low pressure here. So it created a bunch of low pressures in a lot of locations, because it didn't move in a straight line, because little elemental bits don't like straight lines much. They're straight in the sense that they're straight this way, and then straight this way, and then straight this way, and straight that way. They're straight, but they're straight like a lightning bolt. They don't necessarily go in a straight line. They're going in straight segments of momentum. So anyway, so the absorption is in all kinds of directions. The gravity you're falling into is the gravity essentially made by the stuff on the other side of the Earth moving towards you. There's a bunch of junk. There's even another human being on the other side of the Earth that's pushing. His feet are pushing on the Earth. And when he's doing that, his little bits are moving towards the Earth. And as they move towards the Earth, they're absorbing energy that theoretically would have gotten to me, and it doesn't get to me, and that's what I'm falling into. I'm falling into what all the other matter on the Earth is creating in terms of its gravity. So I'm not involved in some active process of making the gravity I'm falling into, of absorbing. The interaction happening on this level isn't the interaction we're involved in. We're not doing the elemental gravity thing, we're doing the collective gravity thing, and the two things are a bit different. So we don't need to communicate with each other. And obviously when objects are really close in the subatomic level, the speed of light is very fast, so they can communicate very fast because it's very short distances. Our gravity has to communicate over very long distances, and obviously it'd become very ineffective if you had to wait for the signal to get all the way to the one object, create a low pressure. It pushes into the emptiness. It absorbs energy going one way because there's less pressure coming the other way. I mean, it's just an obvious argument. There's three things coming this way. There's four things coming this way. Obviously the four things are going to push one unit of energy in this direction as a net. So as we sit here on the Earth, there's a bunch of movement inside the Earth. and all that movement, there's stuff going this way and there's stuff going that way, and obviously I'm feeling, okay, the byproduct of the stuff that went this way, because that represents a bunch of energy that never got to me, and therefore the energy coming down on me has more bits to it, more components, and it ends up giving me momentum down into the earth, and then the earth pushes back because it's solid matter, and so then the gravity ends up being the chemical forces, the forces binding the atoms together, the things that start to pressurize. So gravity essentially gets turned into a kind of heat. Pressure and heat are essentially the same thing. Alright, so I think that takes care of the aberration argument. So I guess I'll just do a summation and keep it simple. So the basic mechanism is to move, you have to absorb energy. If you go from one place to another place, the obvious net equation would be you occupied forces going this way more time than you occupied forces going that way. And by occupying them more, you change the universe, the things that the stuff, the force here, it was heading for something, it didn't get there. It not getting there when you're the thing, okay, is going to be relevant to you. The stuff going away from you, yes, you just have no way of knowing about that, so there's no balance. So perspective means you have an asymmetry. You can only see in the one direction, in the sense of stuff moving away from you becomes invisible. It loses any meaning. So you could sort of understand if the light was made of stuff, and there was a big thing that was moving exactly the same speed as the light, you can understand the light would never catch it, right? Because they're both going the same speed away from each other. So you can sort of understand that absolute movement at an absolute speed means that if you are relying on reflecting photons off of something to see it, you can't reflect this photon off of this object and send it back to see it. So it's invisible. And the same kind of idea functions for gravity. So first, your perspective is dictating what you're seeing, and in any direction you're seeing it. You're seeing the universe sort of asymmetrically. You're only seeing stuff that's not moving or moving towards you, and you're having a hard time seeing stuff that's moving away from you. A harder time feeling it, knowing it, realizing it. And then the other argument is that motion doesn't have to be directly in a direction. So any motion in a certain direction increases proximity to an object, and that is why gravity ends up being spread and ends up being called a weak force, is because the gravitational action will have as its effect, that is, you're going to get hit by some piece of force in that direction, will be easier for the force to act. Say if I take away force moving this way, okay, like I have an extra bit, and I'm going to compensate for a force going that way. Well, let's say an absence of the force is easier. So there's this force didn't get there. Let's just understand. Okay, so there's a missing bit of force going this way. Okay, pushing something this way. Well, obviously, if this thing hit and that force also hit at the same time, the way it was supposed to hit, the action would be in some direction like this, right? The action would be that would be the action, the interaction, the net effect of those two forces hitting. If this force doesn't hit, then the net effect is going to be this, right? So the universe changes based on the absence of that force, in that it doesn't compensate for this. It leaves a hole for this to change the path, and it takes advantage of that hole, and it can take advantage of it from any direction that has a component in this direction. So all the thing needs is a component in the direction of the perpendiculars, and that counts in a sense as a change created by the absence of this. So the absence of this, because it got trapped here for a while, the absence of that doesn't change just things moving this way. It changes things moving any one of those directions. So any direction will be changed if the interaction was going to be this plus this. Obviously that result is different than this, okay, plus nothing. That action, these two worlds are going to be different worlds, okay. Having the interaction and not having the interaction changes what happens. Alright, so I think that's probably enough. I mean, it explains the two key things. First, where does the energy come from? This system has energy, okay? It works as a mechanical model. It's called mock gravity. They actually teach it when teaching relativity, Einstein's spent space theory, because it duplicates the convergence. It duplicates the idea that in 3 dimensions, spent space means you have a convergence of a kind of convergence of pressure on all these objects, and all you're really doing is changing the pressure field. And if you put another object in the pressure field, obviously they'll become shadows that will be cast by these two objects. They will cast a shadow on each other and create a low pressure between them, and that will create exactly what Einstein's gravity is describing as bent space. It will create the bend in the space relevant to the two objects. And again, if you understand that their motion, the objects that you're interacting with gravitationally have a whole bunch of gravitational objects in a collection, and it's that the collected byproduct of all of them doing their gravity in all kinds of directions means that the gravity spreads in all directions, and it isn't just here, it's every direction becomes gravitationally relevant when you're talking about big objects, because they have motion in every direction. Inside of you right now, there's stuff moving in every direction, and by moving, it's absorbing a piece of energy for a moment of time. And so for a net moment of time, in every direction, you're creating gravity by having your little bits move. They've absorbed energy that would have gone somewhere else. It didn't get there. It imbalanced that environment for something else, and that imbalance means something's going to move the other way. So if I move this way, eventually something's moving this way, and that's sort of the rule. But it's an eventually, okay? It's not a instantaneous, and it's the very fact that it takes time that ends up creating the net gravity. And again, the other argument is the simple perspective argument that I can't see the balancing force. So I can't see the fact that the Earth is at equilibrium. So it has a temperature equilibrium. It has stuff moving inside of it that's creating temperature. Okay, gravity is tension inside of it. It's moving objects to make the gravity. But I'm only seeing this part of it. I can only see the change here. I can't see how it changed the universe over here. I can only see how it changes what's coming into me. I can't see what it changed away from me. So those two components, the fact that gravity spreads and the fact that your perspective means you only see change in one direction. You can only feel the stuff moving this way. The stuff moving this way inside the Earth, you know, if you're standing here, you feel it. Okay, you feel the effect of that energy being absorbed. You can't feel the effect of the energy being absorbed in the other direction away from you. So those two simple principles pretty much explain how a particle force model of little bits of quantized energy, it's all quantum still, it just isn't their quantum mechanics. It's quantum mechanics, it's just not their quantum mechanics, which has a bunch of wavy things and entanglement and estrangement and all kinds of spins and other bizarre stuff that you don't need to explain this elemental force. So, I think that about does it. So we will, we'll do an update of this in another month or two. But again, I think the 4 videos are solid. They've explained, some of the experiments and some of the evidence and what we see and why we see it. And again, I could explain the inverse square law, but it's kind of fundamental to understanding that if you have rays coming out of something, if I'm shooting little bits of chalk out of a center of my gravity, so to speak, that all the little bits are diverging through space. And, you just draw a square, understanding that they're diverging in both directions, this way and this way and this way and this way. Draw a square, and that's the inverse square law. The area keeps getting much bigger as I separate these two objects. The area is 4 times different, not twice as different. So I go half the distance, I've created 4 times the area of separation. And so, it's pretty easy to understand. So, anyway, that's, we'll call it a video, and see if anyone can make any rational counter arguments to why this simple theory doesn't satisfy the conditions, explain the experiments, explain what we see, explain the universe that exists, and does so without magical bent space and virtual photons and bizarre, superluminal quantum entangled communication or any of that stuff. All that woo is completely unnecessary to explain the functions of the universe. Is that right? Oh, yeah, it doesn't. No, almost looked like it was paused. Anyway. So, till next time and such.